Hello students, welcome to Soros's classes. In this video, we will be solving a question from ISS paper 2015 paper 1. Now here we have a line segment that is of unit length. So we have a line of unit length. So suppose this is our line of unit length. So here we are choosing 2 points of random. Suppose this is the 2 points that are chosen at random. This is P1 and this is P2, and these 2 points are breaking the entire line into 3 segments. These are the 3 segments. So we have to find the probability that each of these 3 line segments will have a length greater than 1 by 4. That is, the length of each of these 3 line segments are greater than 1 by 4. So suppose this first segment, length of first segment is equals to x and length of second segment is equals to y. Then the length of third segment would be 1 minus x minus y. After all, the length of the entire line, this line, is equals to 1. So the length of this third segment is 1 minus x minus y. Now here it is given that these 3 line segments will have length greater than 1 by 4. So what we are saying that x should be greater than 1 by 4 or x should be greater than 0.25. And so this, take it as equation 1. Similarly, y should be also greater than 0.25. Now this 1 minus, the next is 1 minus x minus y. This part should also be greater than 0.25. So this would imply that x plus y, this should be less than 0.75. So x should be greater than 0.25, y should be greater than 0.25, and x plus y, this should be less than 0.75. So these are the 3 equations. Now what we are going to do is we are going to have a graphical representation of these 3 equations. Now, so let me change the color. So here, suppose this is the x-axis, this is x-axis, this is y-axis, and suppose, so it's 0.51. Similarly here, so it's 1, it's 0.5. So this line is 0.75, it's 0.25, here it's 0.75, 0.25. Now this third one, that is x plus y, is less than 0.75. So this shaded region, this region is the graphical representation of equation number 3. Then from equation number 1 we have x is greater than 0.25. So here we will have, now let me change the color again. So x is greater than 0.25, so it would be like this. And then we have y is also greater than 0.25. So then we would have, let me take this as a color. So y is also greater than 0.25. So the area is this one. This triangle is the desired area, that is satisfying all 3 equations 1, 2 and 3. Now this point, the coordinates of this point is 0.25, 0.25 here. Now in this point here, the value of, now here our y is equals to 0.25. Now putting y is equals to 0.25 in equation number 3, we will get our x is equals to 0.5. So this point is 0.5, 0.25. Similarly, the coordinates of this point is 0.25, 0.5. So we get the coordinates of these 3 points. Now the area of this region, so it is half into base into height So what is this? This is the favorable area. Favorable area. So this is equals to half into base into height. Now here base is, now our base is 0.25. As we can see, 0.5 minus 0.25 is 0.25. So base is 0.25 and height is also 0.25. So into again 0.25. So this is equals to half into 25 into 25 by 100 into 100. So this is equals to 1 by 32. So the favorable area is equals to 1 by 32. Next we would find the total area. Now x can be the length of x. If we do not take into consideration this conditioning that all the segments should be greater than 1 by 4, so this length of x could be 0 to 1. Similarly, length of y could go from 0 to 1. So the total area, so if we draw the graphical representation of total area, this is x-axis, this is y-axis, so it's 0.51, here it's 0.51. So the total area would be like this. This is the total area, that is the sample space. So this is the total area or sample space. So total area or sample space. So this is equals to half into base is 1 into height is also 1. So this is equals to 1 by 2. Then the probability would be equals to favorable area divided by total area. So this would be equals to 1 by 32 divided by 1 by 2, which is equals to 1 by 16. So the probability that each of the three line segments will have length greater than 1 by 4 is 1 by 16. So this is the answer.